So, thank you all for joining me for lesson 2 of the summer geometry course. Today, we're going to be covering common geometry terms. So, lesson 1 was all about just a review of algebra, definitely necessary to understand geometry. Today, it's going to be full geometry, and we're going to be going over some of the basics, some of the things you must know if you want to even have any hope of understanding anything else this summer. So actually, before we even get to the first page of this packet, whether you want to write in the space above or on the margins or whatever, I have blank sheet of paper right here. Anyways, what I want to tell you is that we need to know the most very basic, which is two things, what a line segment is and what an angle is. So here's an example of a line segment. Let's say we have line segment MN, and it looks like that. It's literally just a line capped off at those 2 points M and N. And what you would call this line segment MN. Now, MN can have like a length, like let me give it a length, 3, great length. You would not write MN equals 3 like this. If you want to say MN is 3, you need to write it like this. What's the difference? Obviously, one has a bar on top, the other one does not. You do this one for numbers, and you do the other one for congruency. And we'll explain what congruent means in a second, but this is the major difference. I'll let you write this down for a second. And then similarly, going on with angles, we have this. Let's say I have angle X right here. I have angle X. I guess I'm writing the X in the wrong spot. It should go at the vertex, like right here. So if I have angle X, how I'd write that is I'd write angle X. And it may look like the exact same thing, but this little angle symbol is the actual symbol. Like this is a picture, just like my line segment. Angle X is like the notation. And again, if you want a number, like let's say it's 30 degrees here, then what you'd write is measure of angle X equals 30 degrees. And don't worry, we're going to be looking at this a lot more as the lesson goes on, but just so you have your feet wet, you can at least understand what I'm saying for the next hour. And with that, let's look at the actual first page. We're now ready for page 1. Before we were ready for page 0. So, congruent. We need a definition for congruent. It's like equal, but for, I'm just going to say geometry for now. That's not the best explanation, but it's going to do for now, okay? And here we have line segment AB. Again, I would call it line segment AB. And down here you have line segment CD, which I would call CD, with a bar on top of it, saying it's a line segment. Now, let's say both of these are 6. Like AB is 6 and CD is 6. It doesn't matter which way they point. They could be pointing in the same direction, opposite directions. But as long as they're both 6 units, whatever the unit is, I don't care, then we would say they're congruent. And the way I'd write congruent is I would say AB, line segment AB, is congruent to line segment CD. This symbol right here, that symbol means congruent. It's like an equal sign with a tilde above it, and that's exactly what it is. Okay, next we have the angles. You have angle E here, and then you have angle FGH, which there's actually 3 different ways you can write angle FGH. One is you can say angle FGH because it's all 3. It starts at F, hits G in the middle, and then hits H. Or you could write, if you want, you could also write HGF. Or if you really wanted to, you could just write angle G, which is definitely the easiest way of writing it. The reason why I would not write angle G is because whenever they give you 3 letters, chances are they want you to use all 3 letters, as opposed to angle E, which I only gave you the 1 letter. So it's just one to use. And what I would say here is if I want to say that these angles are congruent, then I would write angle E is congruent to any of the 3 I just wrote down. Let's say angle FGH. And that's how you write congruent. Any questions so far, except for the person who just joined? You don't count. Okay. For anyone who does join late, you can always watch the video, catch up. Luckily, we're just on the first topic, so you didn't miss much. Next, we're going to talk about the midpoint and the mid-segment. Midpoint is just a fancy word for the middle of a line segment. That's all it is. So let's say that this is cut in half exactly, and the way you'd represent something getting cut in half is you'd write little tick marks here, like this. What this is saying is that the line segment from IJ is equal to the line segment JK, or congruent instead of equal. And what you would write in geometry terms, you would write J is the midpoint of line segment IK. Line segment IK. What this also means, whenever you have a midpoint, it means that, for instance, IJ, line segment IJ, is congruent to line segment JK. One thing you're going to notice in this lesson, I'm going to be throwing a lot of terms at you. You're going to try and do your best to learn everything you can. We're going to do some example problems at the end. It should all make more or less sense. And then you're going to finalize your understanding during the problem set, the homework. And believe me, if this doesn't all make sense by the end of the day, that's okay. The goal is not to understand everything the first time around. The goal is to see everything this summer before you see it in the fall. Next is a bisector. A bisector, we need to know this definition as well. It cuts something in half. Cuts something in half. So whenever you see the word bisect, it means it cuts it in half. So in this angle example, we would say line segment MO, right here down the middle, bisects the angle LMN. Look at LMN. It's the outer angle. L, go to M, go to N, and MO bisects it, cuts it in half. When you cut something in half, it means that that is equal to that. Notice the symbols I just drew, this little arc, whatever you want to call it. The fact that there's one arc means they're congruent. And sometimes you're going to have more than one angle congruency theorem in a problem, and I'll show you what to do for that. If you don't know what I'm talking about, don't worry. A lot of this is going to be confusing for the first half hour. Okay, next, in this right example, there's actually two things you could write. The first thing you could write is line segment RS bisects angle PSQ. In other words, PSQ is just like kind of, you're not even sure if it's an angle, but I'll tell you, it's an angle that's 180 degrees. It's just a straight line. And RS cuts it in half. And then the other thing we can say is, well, you could say RS bisects the line segment PQ. Line segment PQ. In other words, RS cuts PQ in half. And the way you'd represent that on the picture is by drawing two tick marks there and there. Now, one more note I want to make before we go on to the next page, and that is the symbol for perpendicular. I think all of us, maybe you don't know what perpendicular means, in which case I'll tell you. Perpendicular is two things that slice each other in half at a right angle, 90 degrees. In other words, I think we can all agree that this looks like a 90-degree angle, and so it gets that symbol right there. That symbol means perpendicular. Well, actually, it doesn't mean perpendicular, it means right angle. But right angle can also mean perpendicular. And I'll explain that in the next page. Any questions so far? Okay then, now we're on to the next page. Parallel. I think we all know what parallel lines look like. If not, they look like this. And basically, parallel lines are lines that never intersect. They are never going to touch each other. T is never going to touch U. That's because they're parallel. And the way you'd represent that is you would say line segment T is parallel to line segment U. That symbol right there means parallel. It's two long lines in the middle. Now for perpendicular. Perpendicular, we kind of just saw it on the last page. Perpendicular means they intersect. I spelled intersect wrong. Intersect at a 90-degree angle. Now remember, 90-degree angles are the same thing as a right angle. These two words mean the exact same thing. So what you would say in this case, you would say line segment YW is perpendicular to line segment VX. Yes, that is literally the symbol for perpendicular. It looks exactly the same as what we have right here. Now, the one thing I do want to say, I'll give you a second to write this down, but the one thing I do want to say is let's just say hypothetically you had this shape, this T shape with A, B, C, D. How you'd write this one, you would say BD, line segment BD, is perpendicular to line segment AC. Notice even though the T is upside down, this is the symbol for perpendicular. No matter what the shape is for perpendicular, you still draw it that with the upside down T symbol for the official symbol. Any questions by what I mean by that? Okay, good. Next, two more terms, and then finally we're done with vocabulary. And believe me, I know this is a lot, but don't worry. This is probably some of the most vocabulary we're going to see this summer until we get to proofs, which, by the way, if you know anything about geometry, you know that proofs are the worst part of geometry. And that's okay, because I'm going to help teach you. It's going to make sense, hopefully. And if not, please ask questions. That's why I'm here. So first we're going to talk about the altitude. The altitude, first I'm going to draw the altitude on this triangle, and then let's think of a definition together. So the altitude is this line right here. This line right here. It's the line, it forms a right angle. In other words, it's perpendicular to the base. And the definition I would give, there's kind of two definitions you can give. One definition is perpendicular line from the base to the top, because that's literally what I drew, a perpendicular line from the base to the top. The other definition you can give, and I would also accept this one, it's the height of a triangle, right? Like this looks like the height of a triangle. Now, this is not a good definition in terms of when you're actually in geometry class. Your teacher will not accept it, but I want you to think of it like that, at least for now, because this will at least help you get a start as to how to draw an altitude for a triangle. And then we have the median of a triangle. The median, first I'll draw the line, and then we'll give a definition. So the median connects this point here to this point right here. And what's special about that point right there? It's the bisector, in other words, cuts it in half, two congruent lines at the base. So in other words, what's my definition for a median? I would say a line from the top to the midpoint of the base. That's my official definition. You can switch out the midpoint with bisects the base. That's okay too. But I like this definition for now because we know what a midpoint is. It's the center of a line. Now, one thing I want to show you is that let's say I have this triangle right here. I'm actually going to draw this triangle 3 times. Watch this. I'm going to draw this triangle 3 times. I don't know if you have room or not on your paper, but I'm going to draw this anyway because this is important. I'm telling you these triangles are identical to each other. Maybe they're not drawn to scale because I'm not a good artist, but they're exactly identical. This triangle has 3 altitudes depending on where you start from. I'll show you all 3. First is the blue, which is the first one I drew. Remember, the altitude is the guy from the top to the perpendicular to the base, so it's the blue here. I could also draw the altitude starting from this point right here, which is another corner of the triangle. And if I did that, I would get this line right there. Again, needs to be perpendicular to the base. And then the last one I could do is I could draw an altitude from this corner, and that would look something like that. That's supposed to be perpendicular. Notice 3 answers for the altitude. Which one is right? There's no one right answer unless the problem asks you to start from a certain point. I'm pretty sure in the homework I asked you to start from different positions, so it's important that we know how to draw each of those. Now let's do the same thing with the medians. And again, I'm going to draw the same 3 triangles here. Okay? 1, 2, and 3. Okay, so for this one, if I draw the medians, I'll draw them in red. The median, remember, is from this point to the center of your line and then just connect it. I now need to do the same thing twice more. Here's 1, and then the middle of this line segment is about here. So there's my line segment. Remember, cuts it in half. Those 2 sides are perpendicular. And then the last one is the line from here to the midpoint here, which is about there. And again, these are congruent to each other. And again, these are the three medians of a triangle. Any questions on medians and altitudes? Okay, if not, then we are ready for some actual questions. Number one, line segment AB bisects. Remember, bisect means cut in half. So line segment AB cuts MNO in half. What does that mean? It means that MN and NO are equal to each other just like that with my congruency lines. The first question is, what is the length of NO? Well, NO is this guy on the right, as we see in the picture, and since they're equal to each other, that must mean NO is 6. So 6. Now part B. If AB equals 9, what is the length of BN? Look at BN here. BN is this guy right here. Now, one question is, does that mean that this is also 5? And the answer is no. Why not? Because AB was not bisected. I repeat, AB was not bisected. MNO was bisected, cut in half. So then how are we going to find BN? Simple. Let me just draw AB for us. I'm ignoring N for a second. And the reason why I'm ignoring N is because they tell me AB, the whole thing is 9. The whole thing is 9, right? And just this part right here is 5. What's the remainder? Well, it must be 4, right? Because 5 plus 4 is 9. True. So that means the answer is 4. BN must be 4. Hopefully that made sense. You're going to be getting a little bit better each time we do one of these problems. And again, the homework's going to be designed to solidify your strength in this topic. Now we're on to number 2. We have a rectangle. Rectangle WXYZ. Point V is the mid-segment of WX. What's a mid-segment? Remember, mid-segment is the same thing as a midpoint. It just means it cuts it in half, just like a bisector. So what I'm going to write is WV and VX are congruent to each other. That's the very first thing I'm going to write. Okay, I'm going to continue reading. Point V is the mid-segment of WX. We got that. It also says ZV is congruent to line segment YV. So where's ZV? It's right here. And where's YV? Right there? Okay. Now I can't draw this. Why not? Because that's the same symbol I used above. So I need a new symbol to say they're congruent. And what's the best choice? The best choice is 2 tally marks, just like this. There, now they're congruent and they're different from the above. That's what you do. Okay, I'm continuing reading. It says WV is 5 plus X. Let me just write that here, 5 plus X. We also know that XV is 12, so I'll write 12 right there. And then we have ZV, which is 2y plus 3, so I'll write 2y plus 3. And then the last one, YV, is equal to 3y minus 3. So 3y minus 3. And there we go. I've labeled everything I need to. And now I just need to find the value of x, which I can find by remembering, what does congruent mean? Congruent means they're equal to each other. In other words, this guy, 5 plus x, must be equal to Vx here, which is 12. And this is why we spent the first lesson doing algebra, because now I just need to solve an equation. Subtract 5 from both sides, you get x equals 7. There's your answer. And as a matter of fact, if you plug in 7 for x, 5 plus 7, 12, they're both 12. That means they're congruent. Go figure. And now we're going to do the same thing to solve for y. Look at y. Y is the 2 diagonal lines here. And so to prove that, I need to say 2y plus 3 is equal to 3y minus 3. And now I just need to solve an equation again. So what I'm going to do is I'm going to subtract 2y from this side to keep the y's positive. That means 3 equals 1y minus 3. Or you can just write y minus 3. You don't need 1y. And then we add 3 to both sides, and we get y equals 6. And there's my solution for that one. Any questions? Okay, then good. Okay, I'm going to give you another second to write this down. Okay. So now let's continue. Number 3 is probably my favorite question of the night. It's a terminology question. We get to basically prove wrong or right what we were saying before, and we're going to actually get the notation right now. And I am going to ask the audience for each of these. So get ready. For the first one, A, AC is congruent to BD. What's wrong with this? Can anyone tell me? There are two correct answers. One right answer is line segment AC with the line above it is congruent to line segment BD, again with the line above it. If you're going to say congruent, you need to say line segment. If it's naked, it's not good. Because remember, without the line segment, you're saying a number. Now, one thing I could do, there's another answer. Another answer you can say is, you can say AC equals BD like this, but notice it's not congruent, it's equal, and that's fine. And the reason why that's fine is because AC and BD without the line above it is just a number. Like for instance, AC could be 7, BD could be 7, 7 equals 7, that's perfectly fine. You would never say 7 is congruent to 7, that's just wrong. So either this answer or this answer is correct. Now for part B, RS equals 10. Can someone tell me why this is wrong? It is because this is a number. If you want to say numbers, you have to say it without the bar above it. And that is the only correct answer. Why? Because if you say RS, let's say, is congruent to 10, you can't do that because 10 is a number and it's not a line segment, so you can't say that. Part C, XY is congruent to Z and W. Can someone tell me what's wrong with this? For this one, you cannot get lazy. You cannot put the word and think you're okay. You literally have to write two different statements. You need to say XY is congruent to line segment Z, and you say XY is congruent to line segment W. That's what you have to write. Now, I will say one thing you can do, this works as well. I would also accept XY is congruent to Z, and then a second congruent symbol to W with the line segments above it. This is fine as well. I would accept this too. Any questions? Okay. Next, part D, angle JKL equals 30 degrees. What's wrong with this? Anybody? For those watching the recording, there are people here. It's not just me talking to myself. Anyways, what's wrong with this is we're missing the measure symbol, little m. The measure of angle JKL has to equal 30 degrees. And why do we need that? Because you use the measure of angle for any numbers, like this one. Moving on, MN is parallel to OP. That looks right to me. Can someone tell me why it's wrong? Once again, I forgot the line segment symbols. MN is congruent to OP like that. And then the last one, part F, measure of angle D equals perpendicular. That one just looks wrong. Can someone tell me how to fix it? The correct answer is, you can set, there's two correct answers. The first thing you can write is measure of angle D is 90 degrees, because that's what perpendicular means, 90 degrees. Or you can say angle D without the measure. You can say angle D is a right angle. These are the two correct answers. Do you have to write both? No, just one will do. They're both correct. Any questions on number 3 with the terminology? Okay, then let's move on. Number 4, we have line SV is the median of triangle STU. I forget, what does the median mean again? Oh, right. It cuts the base in half. In other words, TV and VU are congruent to each other because V is going to cut it in half because it's the median. We also know that ST is perpendicular to TU. Well, here's ST, here's TU. If they're perpendicular to each other, that means they form a right angle. There's a right angle right there. It also means that's 90 degrees if you want to write that instead. So now we need to find the length of VU, given that ST right here is x minus 1, TV is x squared minus 12, and VU is x. Okay, so how are we going to find the length of VU? In order to find the length of VU, we need to solve for x. Now, once again, you'll notice because of the congruent lines, we can say the two things are equal to each other. We can say x squared minus 12 equals x. And now we need to solve for x. Well, this is not easy. Luckily, we had the algebra lesson last week, so we can solve this. The first thing you need to realize is you need to subtract x from both sides. That will give you x squared minus x minus 12 equals 0. Once you have it set equal to 0, now you can factor this thing. So let me write it on a separate page. We've got x squared minus x minus 12 equals 0. We can now factor this. How does this factor? Well, basically, what are the factors of 12? You got three pairs. 1 and 12, you got 2 and 6, and you got 3 and 4. And since this is a minus sign right here, it means that they subtract from one another, and we need to subtract to get the minus 1x in the middle. Well, 1 minus 12 is 11, or negative 11, which is not right. 2 minus 6 is 4, or negative 4, which is also not right. And 3 minus 4 is negative 1, which is what I wanted. Now we need to figure out, is it 3 minus 4, or is it 4 minus 3? Well, since we want negative 1, I want 3 minus 4. So that means the answer in terms of my factors, first I'll set it up like this with the x's. I'm going to do plus 3 and then minus 4. Now, that's my factors. That's not my final answer. Oh no, that'd be too easy, right? So then the answer is the opposite. X equals negative 3 and positive 4. Now here's a question for you guys. Can I have a negative length for my triangle? No, of course not. So in other words, I'm crossing out answer negative 3 because that's impossible. You can't have a negative triangle length. And so the only answer is x equals 4 only. Now, I don't know why I'm circling that. Again, that's not the final answer. Let me explain. Because what did the question ask for? The question asked for the length of VU. That's this guy right here. And what is VU? Well, VU is equal to x, which we said x is 4. Okay, now we can circle 4 as our final answer. And it's just important that we remember that because sometimes it's not just x there. Like for instance, look at the left one, x squared minus 12. You need to plug in x there to get the final answer. And of course, since they're equal to each other, you should get 4. Just to prove it real quick, 4 squared minus 12, you plug that in a calculator, you get 4. So that's good. They're equal to each other. And then the last question, part B, what is the altitude of triangle SVU? Now look at triangle SVU. I'm going to highlight it in red. Here's triangle SVU, okay? And what's the altitude again? Well, the altitude is like the height of the triangle. I'm going to draw that in blue. In other words, the height of the triangle isn't even attached to the triangle itself. Is that okay? Yes, it is. So now I need to find that length of blue in order to find the altitude. How are we going to find the height? Well, look at that right there. It's equal to x minus 1 because that's what it says right there. And so what are we going to do? We know x is 4. So then 4 minus 1, your height is 3. And there's our answer for the altitude. Any questions on that one? No? Okay, good. Now there's just two more topics we need to talk about today, and then that'll be it in terms of new topics for week 2. I hope you're liking week 2 because this is significantly harder than a lot of the other classes I'm doing this summer. In other words, I have 6 classes I'm doing this summer, all the way from Algebra 1 to Calculus 1 and Physics. In my opinion, you guys are the lucky ones. Geometry week 2 is one of the hardest weeks in this entire summer course out of all my summer courses. So you got really lucky, didn't you? Yeah, that's right. Luckily, week 3 is going to be easier because it doesn't get much harder than this. So now there's 3 kinds of triangles. You've probably heard them before in elementary school, but just let's remember what they are. An equilateral triangle is a triangle where all sides and angles are equal. That's what an equilateral triangle is. All sides and angles are equal. Now, by the way, once you prove that all sides are equal, you've automatically proved that the angles are equal and vice versa. So in other words, I'll just draw a picture here. If I tell you this side is 3, this side is 3, and this side is 3, in other words, they're all congruent, then instantly you know it's equilateral. and therefore the angles are all congruent as well. Isn't that so cool? Now for isosceles. Isosceles is just where you have two sides and angles are congruent. And that's basically the same idea, where if I were to draw it over here, I would say two sides are congruent, so like this one and this one, and then two angles are congruent. It matters which two, by the way. It needs to be these two because they're opposite of the sides. Now, you don't have to understand what that means yet. I'll explain it better in a few weeks, but these sides have to be congruent if those angles are congruent. Okay, so isosceles, two sides and angles are congruent. And then the final one, scalene, maybe you remember. This is where all sides and angles are different. All sides and angles are different. Now, how would I represent that in the picture? I'll show you. So here's my scalene triangle. If I want to say all the sides are not congruent, I would do one tick mark, two tick marks, and three tick marks, because none of the sides are equal to each other. And then for the angles, I would do one arc, two arcs, and three arcs, because all the angles are different as well. And that's what a scalene triangle looks like, marked up, all nice and pretty. Any questions? Okay, now let's do some example problems. Number 5, if triangle DEF equilateral, isosceles, or scalene if x equals 7. So all you need to do here is plug in x equals 7 to each side, and you guys see how many sides are equal to each other. So we'll start with x minus 5 squared. That's going to be 7 minus 5 squared. 7 minus 5 is 2, and 2 squared is 4. So that means that side right there is 4. Next, let's do 4x minus 20. That's the next easiest one. So that's going to be 4 times 7 minus 20. 4 times 7 is 28. Minus 20, we'll get 8. So far, the sides are different. We're at least at isosceles. It's either isosceles or scalene. And now for the last one, 9x minus 3 over 6. That's fun. So 9 times 7 minus 3, all over 6. That's going to be 9 times 7 is 63, minus 3 over 6. 63 minus 3 is 60 over 6. And then 60 divided by 6, that's just going to be 6. So the last side is 6. It looks like we had 4 on this side, 8 on this side, 6 on that side. All sides are different, which means we're talking about a scalene triangle. Now, 2 follow-up questions for you guys. First question is, are any of the angles equal to each other? And of course the answer is no, because scalene, all the sides are different and all the angles are different. My last question is, which side is the longest? So to help you with that, I'm going to draw it on a separate sheet of paper. 4, 6, and 8 were the side lengths. Which angle is the biggest? As it turns out, the biggest angle is the side, or the angle, across from the largest side. In other words, 8 is the largest side, which means the angle across from it, this guy right there, that side must be the largest angle. Must be. Similarly, if 4 is the smallest side, that means this angle here must be the smallest angle. You can write that down if you want. It's not going to be on the homework, but this is a fun fact. And it may or may not show up on another lesson. Who knows? Well, I guess I know. Okay, so that's it for number 5. Now we're on to the next page. And the last topic, the last new topic we're going to talk about today is the distance formula, one of the most important formulas in all of geometry. So the distance formula is going to be a way to find the distance between 2 points or 2 dots or lines or whatever. So just look at here, you have A to B. We're going to find this distance in problem 6, but we need a formula. So here's the formula for distance formula. First, I want you to know that we have 2 coordinate points. We have coordinate point x1, y1 for the first coordinate point, and then we have x2, y2 for the second coordinate point. So in other words, with a, for instance, that's like x1 comma y1. I won't write x1 comma y1. I'm actually going to write, this is -3 on the x, and the y is 4. Remember, it's always x comma y. So -3 on the x, 4 on the y. And then for b, we have 5 on the x and just 1 on the y. And so this is my x1, 4 is my y1, 5 is my x2, and 1 is my y2. So I have all the variables mapped out. I still need the equation, and I will give it to you right now. So the distance formula says d distance equals the square root, and it's a ginormous square root. It's going to take up like the whole box, or at least half of it. And that's going to be the first spot's going to be x1 minus x2, close parentheses squared, plus parenthesis y1 minus y2, close parenthesis squared. Here's why the distance formula is hard to remember. You're going to forget that inside the parentheses is minus, and in the middle there's a plus. It's very easy to get confused with, so you need to study this. Okay? Now let's go ahead and plug in the formula here. So the distance between these 2 points, A and B, is going to be the square root of x1 minus x2. So that's -3 minus 5. That will be a negative number. Doesn't matter. Then that's squared plus y1, which is 4, minus y2, which is 1, and then that's squared. And now we just need to simplify and solve. So square root, -3 minus 5 is -8 squared, plus 4 minus 1 is 3 squared. Now, -8 squared, any negative number squared will become positive. Why? Because it's two negatives make a positive. So in other words, -8 squared is now positive 64, plus 3 squared is 9. That was always positive. And so you'll get the answer, square root of 73. That cannot be simplified. I'm fine with square root of 73. That's our final answer. Any questions on that? Okay. Now, one thing I do want to show you is that what if we mess up the distance formula? In other words, what if we put x2 first? Like, what if we put square root of x2 minus x1 squared plus y2 minus 1 squared? Will we get the same answer? Will we get negative root 73? Well, let's see. So if I think of x2, x2 is now our 5 minus -3. Minus -3 is the same thing as plus 3 because it's a double negative squared. And then plus y2, which was 1, minus y1, which is 4 squared. We get this. You're going to get the square root of 8 squared plus -3 squared. Remember, any negative number squared will become positive. So you get the square root of 64 plus 9, and that's the square root of 73, just like before. So in other words, the order of the x1 and the x2 and the y1 and the y2 does not matter. All that matters is that you're subtracting inside the parentheses. I repeat, subtract inside the parentheses and then add the two x's and y's together. And then the square root. Any questions there? Okay. And then I believe this is the last question of the night, and of course it's the hardest. Using the distance formula, determine if triangle TUV is equilateral, isosceles, or scalene. The way you're going to do this is there's only one way to do this. You need to use the distance formula 3 times to find the distance of TU, to find the distance of TV, and then to find the distance of UV. And then we're going to see if these 3 distances are equal to each other or not. So let's go ahead and do it. First, let's find TU. I'm also going to label these coordinate points. Like for instance, spot U, point U is 1, 1, x is 1, y is 1. T is going to be 3, 6 because x is 3 and y is 6. And then the last point here, V, is going to be 5, 2 because x is 5 and y is 2. So now for TU, I'm going to use the distance formula. It's the square root of x1, 1, minus x2, 3, squared, plus y1, 1, minus y2, 6, squared. And so now that becomes the square root of 1 minus 3 is negative 2, so negative 2 squared, plus 1 minus 6 is negative 5, again squared. Remember, any number squared will become positive, so that's the square root of 4 plus 5 squared is 25. It looks like we get the square root of 29 for TU. We are now a third of the way done the problem. Woohoo! So next, doesn't matter the order, next I will find TV. So for TV, we look at TV. X1 is 3, x2 is 5, so it's the square root of 3 minus 5 squared, plus, then the y values are 6 minus 2 squared. 6 minus 2 squared. And that's going to be the square root of 3 minus 5 is negative 2 squared, plus 6 minus 2 is 4, again squared. So negative 2 squared is positive 4, plus 4 squared 16. Looks like we get the square root of 20, obviously different than the square root of 29. In other words, we know it's not equilateral, it's either going to be scalene or isosceles. And then for the last one, UV. So for UV, it's going to be square root of x1, which is 1, minus x2, which is 5, squared, plus 1 minus 2 squared, because that's the y values. And now I just need to start simplifying. So 1 minus 5 is negative 4 squared, plus 1 minus 2 is negative 1 squared. And so for that, what's negative 4 squared? It's positive 16. What's negative 1 squared? It's plus 1. And so the final answer is the square root of 17. I don't know why I'm circling that. That's not the final answer. The final answer is to say that all these sides are different. All sides are different, which means the final answer is scalene again. Obviously, it's not always scalene, but it was scalene twice tonight. And that's going to do it for lesson 2. Congratulations, you all made it. Definitely do the homework for this week. It's probably one of the most important ones to do because every lesson after this is going to be using this notation with the line segments and the angles. So thank you all for watching. I'm going to upload the recording and the homework in an email later tonight. Have a great rest of your night. Bye-bye, bye-bye, bye-bye.